Problem number 55. Problem number 55, it says a bullet of mass 10 gram. That means this bullet of mass 10 gram. 10 gram means we know this 10 gram is equal to 0.01 kg. 0.01 kg. Is moving horizontally at a speed of 50 root 7 meter per second. There's a speed of 50 root 7 meter per second. It strikes a block of mass 490 gram. This is 490 gram. 490 gram means 0.49 kg. 0.49 kg. Kept on a frictionless track. This track is frictionless, as shown in the figure. The bullet remains inside the block. That means it's a perfectly inelastic collision. It's a perfectly inelastic collision that we have to remember while putting the equation of conservation of momentum. And the system proceeds towards the semicircular track of radius 0.2 meter. This is a track of radius 0.2 meter. Where will the block strike the horizontal part after leaving the semicircular track? Now see, this joint mass will move in this direction. It will come here, 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 here. Then it will start climbing the semicircular track. Now the second part is, will it reach the end of it or will it not reach the end of it? That we have to find out from your knowledge of, you have already done the problem sums of circular motion. So that we have to find out the problem of circular motion. So let's start from the start, right? Now, we go to the, let us consider that the joint mass velocity is say velocity of the joint mass or jointed mass. It means this block and a bullet. Let us consider this velocity speed. Then, from the conservation of momentum theory, momentum of the bullet was 10 gram. 10 gram means 0.01 multiplied by its velocity was 50 will be equal to plus, let me complete this, plus the momentum of this block was 0 because it was at rest. Point mass is 0.49 plus 0 on the joint mass and its velocity is v. From here we get velocity v is equal to 0.1, 0.1 multiplied by 50 root 7, that divided by 50 root over 7, that will divide 0.49 plus 0.01 is equal to 0.5. 0.5. This is equal to the per second. This is one relation that we shall need repeatedly in this problem. What is the velocity of the joint mass when it starts along the horizontal path? Is 0.7. Then what is the kinetic energy of this joint? Kinetic energy, jointed mass, jointed mass. Because why we want to find out the kinetic energy? Because with this kinetic energy, it will start rising the semicircular tract equal to half into 0.49 plus 0.01. This is half m, and v square is 7. If you calculate this, this is 1.75 joule. Now let us do one experiment. We want to first find out how far will it rise? How far will it rise? Right? Now, this is 0.2 meter, and this is also 0.2 meter, and total is 0.4 meter. Let us consider this point is A and this point is B. We ask ourselves, will it reach the point B? Will it reach point B? This is the first question. How will you answer it? The potential energy or energy required to reach point B, energy required to reach B equal to mgh. M is joint mass, M is 0.5, G is 10, H is 0.4. But its energy is 1.75 G. So it will not reach B. So, right, will not reach B. This is one conclusion. Then will it reach A? Energy required to A, that means half the way along the semicircular, is 0.5 into 10 into 0.2 equal to 1 joule. And its energy is 1.5 joule, 1.75 joule. So it will reach A and cross A. And right? So it will cross A, but will not. That is the main issue. It will cross A, but will not reach B. So somewhere in between, it will reach some place in between. Now let us draw this semicircle once again, a little bit bigger diagram, a diagram for easy and clear understanding. This is the center point. This is the center point. This was A, and this was P. And say it will reach P. say, we only write say it will be. And let us say this point P makes an angle theta with a horizontal line, right? And more things. This will have a, since it is going in a semicircular path, this will have a tangential velocity. This tangential velocity we have to find out. Let us say this tangential velocity is v. Say it. Here we have written, say it will reach point P. I also write which makes an angle theta at the center the horizontal line, with the horizontal line, and say uh, its velocity, say its tangential velocity at t is equal to vt. So its tangential velocity at t is equal to vt. Right? Now, further, the points of interest is at this point, the gravitational force of attraction G works downward, and the component of G towards the center is G sine theta. Because we have to find out the centripetal force. Centripetal force is equal to half mv square by r, and that centripetal force will be counteracted by mg sine theta. Also, let us not forget that this distance is 0.2. Anyway, we do not need this distance 0.2 here. Distance 0.2 here. This height is, since this is the radius, this height is r sine theta. This height is r sine theta. And of course, this distance is r cos theta, will not need this. This height is r sine theta. Now, coming to the problem, so its tangential velocity we have said dp. So centripetal force, is equal to mvp square by r, mvp square by r. R is the radius, which is given 0.2. mv square by r equal to mg sine theta. Because the force towards the center is g sine theta, gravitational force component, and it's multiplied by us is m, multiplied by mass m. So mg square by r, mvp, this is becoming a little bit clumsy. So let me write it very clearly once again. Centripetal force centripetal force is mv t square by the radius r is equal to mg sin theta. From here we get f gets cancelled, m on both sides gets cancelled. So here we get Vp square, an expression of the tangential velocity. Vp square is equal to gr, and this is one expression we have got that we shall need later. Now we come to the conservation of energy at this point P, right? We come to conservation of energy at point P. Consider conservation of energy consider conservation of energy at point P, then what we really get that kinetic energy at P, kinetic energy at T plus the potential energy at T will be equal to initial kinetic energy. Initial kinetic energy is the energy with which the body started. It had a velocity v and half mv square. It was initial kinetic energy. And kinetic energy at T is half m vp square, tangential velocity vp. So half m vp square. What is the potential energy at T? Let us consider this is the ground level. This is x equal to 0 level. Potential energy at T is mg into this height is r, from here it is r, and this height is r sine theta. It is r plus r sine theta. This will be the initial kinetic energy is half m v square, half m v square. So we get, from here we do one thing, we remove 2 here, and we put a 2 here. So that we are left with, and also we remove this m. We remove all this. Then we have Vp square plus 2r. R we take outside the bracket. 1 plus sin theta is equal to, now v square is equal to root 7 whole square is equal to 7. Now Vp we have already got, Vp square we have already got gr sin theta. So from here we get gr sin theta plus the multiplication 2gr plus 2gr sin theta equal to 7. From here we get gr sin theta plus 2gr sin theta. So 3gr sin theta plus 2gr 7. Or we can write so or avoid one step here. We avoid one step. So 3gr sine theta is equal to 7 minus 2. From here we get what is the value of sine theta? Sine theta is equal to 7 minus 2gr, 7 minus 2gr by 3gr. 3gr. This is 7 minus 2gr is 2 into 10, r is 0.2 divided by 3gr is 3 into 10 into r is 0.2. If you do this calculation, this is equal to half. Exactly half. So 30 degree. Theta, so we get theta is equal to 30 degree. This is a very important relation. So we get theta equal to 30. This angle is 30 degree. Also, we can get Vp from here. Also Vp Vp square was gr sine theta. So Vp square is equal to G is 10 multiply R is 0.2, sine theta is half. So Vp is equal to, so Vp calculate is equal to 1 meter per second. These are the two important relations that we have got, right? That means the jointed mass will reach the point P and then it will lose its contact. It will not reach above this. And when it reaches P, it makes an angle 30 degree with the center and its tangential velocity is 1 meter per second. We have to see what happens to it after that. What happens to it after that? Now, let us find what happens after that. After that, once again, try to visualize what happens to it after this. So let us draw the diagram once again. Let us say this is the point P. Let us say this is the point P, right? Which is at a height of, r sine theta. This height is r sine theta. R sine theta. R is 0.2 and sine theta is sine 30 half. So this is equal to 0.1 meter. That means vertically it reaches just the half point. This was the center of the curve. And this radius of it was 0.2 meter. Right? So the total height is 0.3 meters till the ground. And the semicircle was somewhere here. You don't need the semicircle, but just to make your visualization clear, I am drawing the semicircle. You don't need the semicircle anyway. This was a semicircle. Right? Now, at this point P, what was this distance? This distance, and This angle was 30 degrees. This angle was 30 degrees. And this radius was R 0.2. Radius was R 0.2. So this length was R into cos 60. This was R, or you can say this is, since this is 30 degree, this length is R into uh, cos 60, because this angle will be 60, and this is R, this is R, this is R. So this height, this length is equal to, right here, this length is equal to 0.260 degree is equal to by root 3 by 10, because this is root 3 by 10. Okay. Now coming back to the problem once again. Here it had a tangential velocity of Vp. It had a tangential velocity Vp. And at this point, it loses contact with the semicircular surface. So what will happen? It will start flying as if it is a projectile. It will start flying as if it is a projectile like this. It is a projectile like this. Now this projectile has an angle of it. This is 30 degree, then this is 30 degree, and this is 60 degree. So the joint body is just a projectile thrown at an angle of 60 degree with a horizontal with a initial velocity v. Then what is the range of this projectile? Any projectile we know is thrown with a velocity vp, and this angle is 60 degree. Then this projectile will take a path like this, and this range up. This formula is given. This range is equal to, formula you need to remember is u square sine 2 theta by u square sine 2 theta by g. We write here when u is equal to projectile velocity and theta is equal to angle. Theta equal to projectile angle. This is the general equation. We have to think of the actual case now. Now, what is the range actually then? So range R will be equal to, now u square is Vp square into sine 2 theta. Theta is 60 degree by g is 10. This is equal to Vp square. Vp is 1, so Vp square is 1, and sine of 120 degree is sine of 120 degree is sine 60 degree divided by 10. This becomes by 20. So this range is equal to root 3 by 20. That means this point here is 3 by 20 away. Now, this point P was at a distance from this line, point P was at a distance towards left by a value of root 3 by 10. And the projectile comes back at root 3 by 20. That means it just covers halfway through. It just covers halfway through. Now, when it comes here, once again, when it comes here, at this point, the projectile falls, we know from the kinematics, with the same velocity, falls with the same velocity Vp. Because it was projected with Vp, it falls with the same velocity Vp and with the same angle. This angle is 60 degrees. And this has a horizontal component, which is, and Vp is equal to 1. And this is horizontal component, Vp cos 60. So this is half. And this is Vp sin 60. So this is. So from this point, start a downward journey. We have to find out where it reaches really. This was the question, where it reaches. It will start a downward journey. We can easily find out how much time it takes to fall from this point P to the ground, which is 0.3 meter away, with the velocity root 3 by 2. And when we find the time, we multiply by that time with the horizontal component of the velocity half, and we shall find out how much this distance it covers. It is as simple as that, right? Now let us say, time to fall to ground equal to T. So from the kinematic equation, this distance is 0.3 meter. 0.3 meter is equal to its initial velocity is root 3 by 2. Root 3 by 2 into T plus half G is 10 into T square. From here we get multiply by 2 on every side. 0.6 is equal to root 3 T plus 10 T square. Plus 10 T square. Now, this is, or you can say, that means it is 10 T square plus root 3 T minus 0.6 is equal to 0. If you solve this, you will find, I am avoiding that quadratic solution. You use the formula just minus b plus minus under root b square minus 4ac by 2a. This is, it will become, so T is equal to, I'm just avoiding 1 or 2 steps in between, minus root 3 plus minus 3 root 3 divided by 20. Now, obviously, T cannot be negative. So we have to take only the positive sign here, only the positive sign at this point. So it will be 3 root 3 minus 2 root 3, or only root 3 is 2 root 3, 2 root 3 by 20 is equal to 10. Root 3 by 10 seconds. So this is the one relation we get. Then we find out how much horizontally it travels by this time. During this time, it travels horizontally. So we come here. During this time, it travels horizontally a distance of time is equal to root 3 by 10, and horizontal velocity was half is equal to 3 by 20 meter. By 20 meter. Now you see the fun of the whole thing. Found earlier, the range was root 3 by 20. That means, coming to the picture once again, the projectile fell at a distance of root 3 by 20 from P, and thereafter x-axis movement is once again root 3 by 20. So total distance, horizontal distance traveled by this is root 3 by 20 plus root 3 by 20 is equal to root 3 by 10. So horizontal displacement, we can write after detaching at point P is equal to root 3 by 20 plus another root 3 by 20 is equal to by 10 meter. Now, the point P, we have seen point P with this semicircle, the point P makes an angle of 30 degree, where this is the radius R. So this is the radius R. So this distance is equal to, this distance was equal to radius R into cos 60. Radius R into cos 60. This distance was radius R cos 60 is equal to R was 0.2, cos 60 is equal to root 3 by 2. This distance was root 3 by 10. And from the point P, the projectile traveled towards right, the same distance point root 3 by 10. So what will happen? Coming to the original picture, from here the projectile will fly and come back to the same point here. From where the semicircular movement started. So we can write, so the jointed mass will fall on the junction of the frontal and semicircular part. Exactly from where the semicircular part started, after flying back, the body will fall once again at the same point.